Welcome guys. So in this video, let's talk about the second ODE, right? So the idea is that, in this video, idea is that I want to prove this statement. So basically, if I have a second ODE, like y double prime equals axy prime plus bxy, and people can define the so-called Wronskian. So it's y1 y2 prime minus y2 y1 prime. Okay, so the idea is that I want to prove that Wronskian w prime will satisfy this equation, so that we can write wx is exponential large capital X, and capital X prime is is the lowercase ax. Okay, so let's summarize the results. So the idea is that suppose we already know. Suppose we already know this one, and then we hope to show w prime is aw. W is defined to be y1 y2 prime y2 y1 prime. Okay, so this type of problems usually people like to ask. Okay, so let's compute w prime, y1 prime y2 prime y2 prime y1 prime plus y1 y double prime plus y2 y double prime, right? So these two terms cancel. So w prime is equals to y1, right? And the y double prime is a y1 prime plus by1 plus y2 a y1 prime plus by1. Okay, so let's say, sorry, this is y2. Okay, so that we have a y1 y2 prime. So this is by1 y2, right? So by1 y2 minus a y2 y1 prime minus by1 y2. So these two terms also cancel. So we get a y1 y2 prime minus y2 y1 prime. Okay, so you see, this is exactly w, right? This is exactly w. Okay, so now we have y prime equals to a w. So w is equals to exponential ax, where ax is the ax double differentiation is the lowercase ax. Okay, so this is the idea. So we can also combine this, right? So basically, this equation that says that if you know w2, then you can solve w1. So this is called the reduction method. Okay, so this is the idea that how Wronskian plays the important role in the second ODE. Okay, and okay, so let me just introduce final property. So there's a final property that I haven't mentioned until somebody told me. Okay, so wy1 and y2, right, is defined to be y1 y2 prime y2 y1 prime, right? So there is a fact that if you take f and g and f and h, then you will become f squared w gh. Okay, so this is the property of Wronskian. So let's give a proof. Okay, so just brute force, right? So it's fg, right? So it's f prime h plus fh prime minus fh fg f prime g plus g prime f, right? So we got the ff power prime gh plus ff f squared. Okay, so now f squared gh prime minus ff prime hg minus f squared hg prime. So these two terms cancelled. We get the f squared gh prime minus hg prime, which exactly is, right? So this is the gh, right? So gh prime minus hg prime. So f squared w gh. Okay, so this is just the property of the Wronskian. Okay, I think it's enough. So this Wronskian can have this formula to connect our second ODE, and also it has some properties. Okay, I think that's it. I will see you guys in the next videos. Be sure to subscribe to my channel.